Physical Science Module 5. We'll be discussing groundwater, soil moisture, and surface water today. Figure 5.6 from your text, groundwater and soil moisture interaction. This picture shows soil moisture being absorbed by plants. You can see that it's rained, and then there's a layer of topsoil. This is soil above the water table. Soil moisture soaks down to the water table, and the water table can only absorb so much water, so then it begins to feed streams that are nearby and lakes that are nearby. When the soil below the water table is saturated with water, it can just only hold so much. It has to leave by feeding those streams and lakes. The soil above the water table saturates quickly, but it will dry out. Once the groundwater has flowed into streams and lakes, the water from above the water table will actually trickle into the groundwater flow. The line between the water-saturated soil and the soil that is not saturated with water is called the water table. Depth changes depending on how much water is available. So the water table isn't static. It can change with how much water is available. If you have an area where there's lots of water, then the water table will be saturated all the time, and there will be a lot of runoff. If water is scarce, it's necessary to go deeper into the ground to find soil that's saturated with water. So the top layer of the soil will be very dry. And as an example, if you're digging a well, when you have soil saturated with water, you can get to the well water quickly. But if you have a dry, arid climate, it will take quite a while to get to the water for the well. The depth of the water table actually increases when water is scarce. So that basically means that if there's less water, you'll have to go deeper to find it. When soil moisture flows down through the soil, we call it percolation, or we say that it percolates. So percolation results from rainwater or moisture in the air hitting the ground and then seeping into the ground and moving downwards towards the water table. If water percolates deep enough, it will go past the water table. Since the water table below the water table is saturated, this kind of percolation occurs only when some of the groundwater has flowed out of the region, making room for new groundwater. So some of that groundwater has to go to the streams and lakes for new water to enter the water table. As a reminder, groundwater is our largest source of liquid fresh water. Groundwater is usually accessed by digging wells. Most groundwater flows quickly at rates up to 50 feet per day. Even when it hasn't rained recently, rivers continue to flow. This is because groundwater feeds the rivers continuously, causing the rivers to flow. Surface water. Lakes, rivers, ponds, and streams of the hydrosphere are sources of fresh water. But not all lakes and ponds are freshwater sources. Some lakes and ponds are saltier than the oceans. Salts are continuously dumped from the soil into lakes and ponds. We've just seen this. When rain percolates into the soil, it brings the salts from the soil into the groundwater source, which eventually goes into streams, lakes, and ponds. A good example of this is the Great Salt Lake in Utah. It's a very salty lake. This lake is about 75 miles long and 30 miles wide. It's about 35 feet deep. 3 major rivers feed into the Great Salt Lake. The Great Salt Lake has no outlets, so the only way it can lose water is through evaporation. Because of this, the salts tend to stay in the lake and not wash away like they do in the ocean. This lake has no fish, but it does have microorganisms and brine shrimp. The Dead Sea in the Middle East is a salt lake. The Great Salt Lake can also look like this if there's lots of precipitation, but lately there hasn't been. The Dead Sea is about 47 miles long and 10 miles wide. It has the lowest elevation of any body of water in the world. Because the climate is so dry, the water evaporates just as quickly as it flows into the lake. The average salinity in the Dead Sea is 300 grams per kilogram. That is very, very salty. And what you see on top of that water is salt. Those are salt pillars. The last source of water from the hydrosphere for discussion is the atmosphere. When water enters the atmosphere through evaporation or transpiration, it's held in one of 2 forms. It will be there in water vapor, which creates humidity. And think of mornings where it's drizzling or it's foggy, and also in clouds. What I want you to do is go on and complete your On Your Own problems 5.8 and 5.9. We will observe Lab 5.3 in class and then continue our discussion about atmospheric moisture in video 5F.2. Have a great day.